Good morning, my dear students. Today we have a new lesson in algebra, which is imaginary and complex numbers. If I ask you to solve the quadratic equation x squared plus 1 equals 0. So you will isolate x squared in one side. It will be x squared equals negative 1. After that, to undo the power or the square power 2, we're gonna take positive or negative root for negative 1. But in fact, we know that root negative 1 is no real solution. So the solution of this equation in real numbers is 5. In the set of real numbers, we know that negative numbers don't have a square root. So imaginary numbers were invented so that negative numbers would have square roots and certain equations would have solutions. These numbers were devised using an imaginary unit named I, so that I equals root of negative 1, or we can say that I squared equals negative 1. It means we have a number, when we square it, the result will be negative 1. So its root or the two roots of negative 1 are positive and negative I. So the imaginary numbers consist of all numbers in the form of bi, where b is a real number and I is imaginary unit, with property that I squared equals negative 1. Now let's see the first four powers of the number I establish an important pattern and should be memorized. Powers of I. We know that I power 1 is I itself, and I power 2 equals negative 1. Now, what about I power 3? I power 3, you studied before that you can express I power 3 as a product of I power 1 by I power 2. So it will be I times negative 1. So I power 3 gonna be negative I, which is the product of I and negative 1. So I power 3 now is negative I. What about I power 4? I power 4, you can express it as the product of I squared and I squared. So it will be negative 1 times negative 1. So it will be 1. Now we should memorize the powers of I, that I power 1 is I itself, I squared equals negative 1, I power 3 is negative I, and the I power 4 equals 1. And then you can make this as a pattern. So if I have I power 5, it will be like I power 6, it will be like I squared. If you have I power 7, it will be like I power 3. Also I power 8, it will be like I power 4, and so on. Or if you have a number greater than 4 in the power, like I power 31, like power 102, any number, so we will divide the exponent or the power by the number 4. And we have 4 cases. If no remainder, so the answer will be 1. If no remainder, so the answer will be 1. Like what? Like I power 4, I power 8, I power 12, I power 16. It means multiples of the number 4. If the remainder if we have a remainder of 1, it means the answer will be I. Like I power 5, I power 9, I power 13, I power 17, and so on. Also, if I have a remainder of 2, so the answer gonna be negative 1. The answer will be negative 1, okay? Like I power 6, I power 10, I power 14, I power 18, and so on. And if the remainder of 3, so the answer gonna be negative I, negative I. Now, let's take the first example. Find I power 23. So we're gonna divide the exponent by 4. You will see that the remainder is 3. When the remainder is 3, so the third number, which is negative I. Okay? What about I power 2006? 2006, when you divide it by 4, you will see that you have 2 as remainder. So it will be negative 1. I power 37, if you divide the exponent 37 by 4, you will have a remainder of, yes, of 1. It means the answer is I. Now, a number like 828, when you divide the exponent by 4, so the remainder is 0. It means we have the number 1, or like I power 4. Now we have the complex number system. We know that, or we studied before, the natural number in grade 5, that numbers like 1, 2, 3, 4, 5, and so on, or in some books we can say that the natural numbers like 0, 1, 2, 3, 4, okay, and the whole numbers like 0, 1, 2, 3, 4, 5, 6, okay. We know that the natural are subset of the whole numbers. After that, we studied integers. We studied integers in grade 6, and we know that the whole numbers is a subset of the integers, okay. After that, in grade 7, we studied rationals like fractions and decimals in first prep, and we know that integers are subset of the rational numbers. And in prep 2, grade 8, we studied the irrationals, like they have no fractions, like pi and like the exponent e, okay, exponential number e. And we know that the union of the rationals and irrationals give me the real numbers, real numbers. Now we have new numbers that are imaginary, like I, 2i, negative 3 minus 7i, and so on. So we have a complex number. Now, let's see second example of our lesson. The second example here, if I ask you now to find the value of root negative 5, express this number in the term of I. We know that we can rewrite negative 5 as the product of negative 1 and 5. So it will be negative 1 times 5 like this. And then we know that root of negative 1 considered as the number I, the imaginary number I, and root 5 as it is. So the answer is like negative 1 times root 5, root negative 1 times root 5, or we can write it as I root 5. Now, another example. If I have negative square root of negative 7. So in this question, we will not use the negative which is outside the root. We will keep it as it is in each step. So we can rewrite negative 7 as the product of negative 1 by 7. Now we can write root negative 1 as I and root 7. So the answer will be negative, which is outside, times I, which is root negative 1, times root 7, or negative I root 7. Another example, if I have root negative 99. So we can express it as negative 1 times 99, and root of negative 1 is I. So the answer will be I root 99. And then like second prep, that 99 is the product of 3 by 3 by 11. So I can write it as 3i root 11. 3i root 11. Now you can try number 6 and 7 and 8. Okay, this is the answer to check your answer. Now we have second part, that adding and subtracting and also multiply imaginary numbers or an imaginary number by a real number. It's important first to express the imaginary numbers in the term of I. Look, if I have 47i multiplied by 2, so it will be 2 times 47, it will be 94, and put I as it is. If I have 2i times root negative 5. So in this question, we should rewrite the number root negative 5 in terms of I first. So 2i as it is, the first one, and we know that root negative 5, we can express it directly as I root 5, like this. Now, when you multiply numbers, real numbers together, 2 times root 5, it will be 2 root 5. And the I times I, it's gonna be I squared. And we know that I squared equals negative 1. So it will be negative 2 root 5. Example number 11, if I have two roots like this, multiply together, so we're gonna write them in form of I first, like the previous examples. So the first one will be negative I root 3. The second one will be I root 7. Now when you multiply the real parts together and multiply the imaginary parts together. So we'll multiply root 3 times root 7. It's gonna be root 21. Okay, and I times I, it's I squared. So we have negative and I squared and root 21. I squared equals negative 1. So it will be negative 1 root 21. It means it's root 21 without the negative. Now, the complex numbers, it's a number written in the form of a plus bi, like this. The complex numbers consist of all sums a plus bi, where a and b are real numbers, I is an imaginary number or imaginary unit. The real part is a and the imaginary part here is bi. So the real part is a and imaginary number or imaginary part is bi. Okay, so if I ask you to add or subtract, like 7i plus 9i, both are imaginary parts. So we can add them. 7i plus 9i, like 7x plus 9x, it will be 16x. So here 7i plus 9i, it will be 16i. Now, if I ask you to add negative 5 plus 6i as a complex number, plus 2 minus 11i, another complex number. So here in this question, try to add the real parts together and the imaginary parts together. So the real parts here we have negative 5 and 2. Add them, it will be negative 3. And 6i plus negative 11i, it will be negative 5i, the imaginary parts. So the answer of this question will be a complex number in the form of negative 3 minus 5i. Number 14, if I ask you to subtract, we know that to subtract, it means you will distribute this minus in the second part or in the second number. So we will write the first as it is and the opposite of the second number. So it will be 2 plus 3i minus 4 minus 2i, minus 4 minus 2i. Now you're going to add the like terms 2 and the negative 4. It will be negative 2, 3i, and the negative 2i. It's going to be 1i. So we will write it as I. Like 1x, we write it as x. Now, multiplying and dividing complex numbers, like if I ask you to multiply 3i by 4i, we will multiply 3 by 4, it will be 12, and I times I equals I squared. So 12i squared. Now we know that I squared equals negative 1. So the answer will be 12 times negative 1 or negative 12. Now if I have 7i all squared, it means 7i times itself. It means 7i times 7i. It means 7 squared or 7 times 7 equals 49. And I squared, which is negative 1. So 49 times negative 1 equals negative 49. Also, you can try this. Now we can check your answer. Okay. Now if I ask you to multiply 4 plus 3i by 7 plus 2i, it's look like what you had studied in first prep, how to multiply two binomials like this. You will use FOIL method. Why? First by first, 4 by 7 equals 28. And first by second, 4 by 2i, it will be 8i. Then 3i by 7, it will be 21i. Then 3i times 2i, it will be 6i squared. After that, combine like terms. But we know that 28 as it is, 8i and 21i, they are like terms. It will be 29i. And then 6i squared. We know that I squared equals, yes, -1. So you can change the sign of 6. It's gonna be -6. So 28 plus 29i minus 6, like this. Now combine the like terms again. We have 28 minus 6, it will be 22. So the simplest form will be 22 plus 29i. Okay, you can try this example and then check your answer. You remember we have two numbers like first prep, sum and difference of the same two numbers? Yes, let's do it. 5 by 5, 25. 5 by -7i, -35i. And then 7i times 5 equals positive 35i. Then positive 7i times negative 7i equals negative 49i squared. Then combine the like term, you will cancel the middle. You will see that 25 minus 49 times -1, which is 25 plus 49, which is equal 74. And when we complete the lesson, we will have another way to solve this type of questions. If you understand conjugate numbers, you studied the word conjugate also in second prep. Conjugate of a plus bi is a minus bi. Here you must remember that to find the conjugate number, change the sign of the imaginary part. Even the imaginary part is the first. So change the sign of the imaginary part. So the conjugate of a minus bi also is a plus bi. So the first one, its conjugate is 3 minus 4i. Now it's -4 plus 7i. What about if I have only 5i? Its conjugate is -5i. What about if I have the number 6? It's 6 as it is. Why? Because we don't have here imaginary number. So 6 plus 0i, it's look like 6 minus 0i. Now we use the conjugate to divide complex numbers like this. So in division, we can divide by using the conjugate by multiplying up and down by the conjugate of the denominator. So multiplying all the fraction by the conjugate of the denominator. So when you see down 1 minus I, it means I will multiply up and down by 1 plus I over 1 plus I. Because here I just multiply by 1. The value of the fraction will not change. So we studied now how to multiply using distribute. So we will multiply up and multiply down. Then combine the like terms. we will see that the answer will be negative 7 plus 2i. I know that we explain it quickly because we understand how to multiply. Here I just multiply negative 1 by 5, then negative 5 by 1, then negative 5 by I. Step 3, positive 9i by 1, then positive 9i by I, like this. And down the same. Uh, or down you can say that because the two numbers are conjugate to each other, so the product of them is the first square plus the second square, or minus the second square, like this. Or it will be 1, the square of 1 1 minus I squared. It will be 1 plus 1, which is 2. Now negative 14 over 2 is negative 7. 4 over 2 equals 2. It will be 2i. So the simplest form of the number equals negative 7 plus 2i. Also, you can try this. It's the same. Thank you, and see you inshallah in another lesson. Goodbye.